All right. So this is worksheet, the notes are worksheet 14. The assignment is 15A. And then during the workday, you'll work on 15A, all of 16 and 17. All right, ready? All right, you do need a graphing calculator today. We're going to talk about inequalities. So we're talking about greater thans and less thans as related to polynomials and rational functions. So we got two different concepts here today. All right, inequalities related to polynomials, and then inequalities with x's in the denominator, which are called rational functions, okay? We're going to use our graphing calculator and do as much of it as we can on there. We're going to use what is called a sign chart today, where we're going to put, is the graph positive or negative between individual values, and then we'll use that little sign chart to write our interval notation. All right, when you have a polynomial function or polynomial inequality, you can basically look at the graph. You want to find all the zeros. So we wrote those on this little chart down here. We have -4, -2, 2, and 5. And then we just look at the graph and we say, out this direction, it's positive, right? It's above the x-axis. Everybody okay? So we put a positive here. In between these two values that were -4 and -2, it was negative. Everybody see where I'm getting this now? In between here, the graph is positive again. In between these two values, the graph is negative. The y values are negative. Out beyond here, the y values are also negative because it had a bounce. All right? So then it depends what the question was. If the question said, where is this polynomial less than 0? You'd pick all the intervals where it was negative, right? And you'd say it was negative in between -4 and -2, and in between +2 and +5, and again after 5. You got to be a little bit careful. If it didn't say can equal 0, then you can't include the 5, so you get two separate intervals here. If it had said maybe, you know, greater than 0, then you would have said here and in between here. Just depends what the polynomial, what they ask for. So on your homework, this is the notes worksheet actually, not the homework, but 14A, is this right, guys? Do I have the right number? Yeah. Okay. So it starts with a polynomial function. You always want to make it compared to 0. It's so much easier. So you're going to move the 3 over, and that makes it a -18. This one factors, so you can find the zeros exactly by factoring. So it says we have a 0 at -3 and a 0 at 6. I really hate what they did down here. I'm just going to redraw this. We have a 0 at -3 and a 0 at 6. Now when you make your little sign chart, we're going to have some that have fractions and decimals. Make sure that it makes sense least to greatest, okay? If you screw up the numbers on the sign chart in the order you write them, then you have a problem. All right, we only have two values. We probably wouldn't even need to type this in our calculator. We're pretty smart. This is a parabola that opens up with a 0 at -3 and +6, y-intercept at -18 back here, right? So we have a pretty good idea what it looks like. I did graph it on the calculator and give you a little screenshot right here. But what's it doing off to the left of this? Is it positive or negative? The y values are positive. In here, between -3 and 6, it's down below, it's negative. You could also test, if you put a 0 in over here, you'd get -18 out, right? So it's negative. Over here, to the right of 6, the values are positive. So then you look at what it asked. It asked where it was greater than 0, which means what numbers are our solution? Greater than 0 is positive numbers, yes? Okay, so we want to say this works and this works. And then you guys are way ahead of me. You're trying to write the interval notation, right? From -∞ up to -3 works. and 6 to infinity works. Now, why didn't I use any square brackets? It said greater than 0. It didn't say greater than or equal to 0. If it had said greater than or equal to 0, the -3 and the +6 would have had square brackets. Everybody okay? Muy bien. All right. Part B says x squared plus 2x plus 2 is less than 0. If you graph this, first of all, if you try and factor, it doesn't work. If you try to do quadratic formula, which I'm going to make you do once today, you get negative solutions, like as in imaginary solutions. When you square root, you get a negative and try to square root it. That's because if you look at this, does it ever go below 0? No. So the answer here is, where is it less than 0 is no solution. If the question, perchance, just in case there was one like this on a homework, said x squared plus 2x plus 2 is greater than 0, what would you have said?
All real.
Good job. All real answer. All real numbers. Yep. Okay, so that's just an example. Be careful. There could be one no solution or all real numbers on a homework. All right, you don't have this one, so please be looking up here. Don't be trying to write this down and then realize that you're writing it on the wrong problem. All right, this was a polynomial function. It said, where is it less than or equal to 0? I can't factor that. I don't know where the zeros are, so I just graphed it. When I graphed it, I found a 0 at 3, so I put that on my sign chart. Then I found a 0 at -1, put that on my sign chart. But then it was kind of, see how it's kind of like bumping up against that, looking weird right here? I was a little concerned because it should have how many zeros? It was degree 3, right? I should have as many as 3 zeros. Now there could be a bounce there, but I couldn't tell. So I went ahead and did calculate the 0. Remember that under second trace you can pick 0. And I found there was one here. What does -0.6666 mean? -2/3. Where should that be? Yeah, -2/3 or -0.6 repeating. Okay, it's here. Does that I wrote that, so it's not good?
-2/3 over -6.
All right, I'll just write -0.6 as approximate, okay? Because I'm going to ask you for a minute for a number in between those two, and if it's written as a fraction, everybody freaks out. But if I tell you it's between -1 and -0.6, you can find it. Like -0.8 would be in between there, right? Okay. Then that's exactly what I did, actually. If you look here, I picked -0.8, and I wanted to see what it was doing in between there, and what kind of a number did I get? Those of you in the back probably can't see, but it says, but it's positive, yes?
Yeah.
So I got a positive number in between here. Now, what was it doing in between these two, between -2/3 and +3? What is the graph doing down here? It's negative. What is the graph doing to the right of 3? Can you tell? It's going up. It's positive. To the left of -1 over here was this piece. It was negative. The other thing you can do, and I might have to wait till the next example, I can't remember. You could zoom in to find that other 0, you mean? It's not going to be nice, though. It's a rational one. It's 2/3. The other thing you could do is all the factors of 6 over all the factors of 3 and test those, remember? Otherwise, you could do synthetic division. I was trying to say you could look at the graph, but I don't think I have that one in my calculator. So if I go all the way to the top here, do I have it? I don't think I do. No. All right, so we'll come back and do one with the calculator in a second. But so what did I want to know about this one? Where it was less than or equal to 0, which means it's, yeah, this symbol is a less than, so we need negative. So it's going to work here and here. Do I include the endpoints or not? because it wasn't or equal to, it is equal to 0 at -1, so I want to include that. It is equal to 0 at -2/3. It is equal to 0 at 3. So I would write -infinity to -1, square bracket, -2/3 to to +3. Sorry, that's a +3. All right, seem okay? Let's try the one you have. Yeah, don't hate. Does this factor? It does not factor.
Yes.
Now, that when it doesn't factor, sometimes that means it doesn't have any zeros. The whole thing is above or below the x-axis, but this has a y-intercept at -2 and it's opening up. What do you think? Yeah, it's going to have some zeros, right? It's doing something like this. Crosses at -2 and it's going up. So we need to find the zeros exactly. So we have to use, you don't have them exactly, because we have to use what? Okay, so help me out. What's the opposite of b is 3 plus or minus the square root of b squared would be 9 minus 4 times a, which is 1, times c, which is -2. What's -4 times 1 times -2? 8 plus 9 is 17. 3 plus or minus the square root of 17 all over 2. So what are the two solutions?
3 plus the square root of 17.
Yeah, and which one would be to the left?
Minus.
Minus the square root of 17 over 2. The one on the right would be 3 plus the square root of 17 over 2. And where is it going to be less than 0? We already knew what the picture looks like. In here, right?
Yeah.
If we tested a value, we put a 0 in here, we'd get out a -2. So it is indeed negative in here. It's positive to the left and to the right. We want to know where it's less than 0, which is where it's negative, so these answers work. Can we include those endpoints? So our interval notation, it's not an ordered pair, it's actually interval notation, is the nice disgusting 3 minus the square root of 17 over 2 up to 3 plus the square root of 17 over 2. Okay, I do hereby solemnly swear there's not one like that on that test, okay?
I'm gonna need to see your hands on top of a Bible.
There might be one on homework where you have to do quadratic, but there's not one on the test. All right, help me with number 2. Does this factor?
Yep.
How's it factor?
X plus 1, X plus 1.
Okay. What would that graph look like? Where's the... Almost everything's positive because it's doing what? It's got a 0 at -1 and it's bouncing. Now, is it actually all positive?
No. Where it is -1, it's 0.
At -1, it's actually 0, right?
But there's no negative.
There are no negatives. Yes, it's not positive or negative at -1. So if I want to know values where it's greater than 0,
I use parentheses.
yeah, how are we going to write that?
Negative infinity to -1. Union to -1 to infinity.
Okay, if we did our little sign chart, we'd have -1 right here. It would be positive over here and positive over here, but because it doesn't have the or equal to, we can't include -1, so that's why we ended up with this. If the silly question had just said greater than or equal to 0, we could have said all real numbers.
But why would it say that? That makes us happy. We don't
All right.
have to be happy.
Number 3, this would make a great test question. Okay? What are you going to do? Subtract the 12. You want to compare it to 0. Now, I can't factor that. So my next thing was to pick up my calculator and graph it. I do have it graphed, so let's just use my graph real fast because it has 3 nice zeros. Can you tell where they are?
That looks like a -3,
+1, -3, and -4. Okay? I think this one is on my calculator. Yeah, it's this third one down here. Second one? Yep. So if I turn that on, the other reason you want to graph it is because now you can test values in between those really easily. If you go second window and turn on Ask Auto, remember this? Now if I go, I just want to know what's going on in between here. Now, some of you, yes, you could just use the end behavior, draw the sketch, and think about it. But look, what's a number below -4? Okay, I put in a -5, I got out -12, so it's negative down here. What's a number between -4 and -3? All right, so I need to type, okay, please move, silly calculator. Oh, you're really ticking me off here.
Silly rabbit.
All right, I don't think I can get it to type without moving it up or down. Come on, silly thing. All right, here, what if I minimize it and re-maximize it? It's going to go in the same darn place. Okay, now will it let me grab it? Ah, there we go. Okay. -3.5 was in between there, and I got a, what kind of number? Positive number. So it's positive in between here. What's between -3 and 1? 0. And what did I get when I put in a 0?
-12.
So it's negative. What's out past 1? I tried a 5 and got 288. Okay. Okay. So where is it greater than 0? In here. And? All right, do I need any square brackets? Nope, just says greater than, can't include any of the endpoints. All right, so on a test you could do that? Okay. Pretty easy.
I think the whole calculus made it seem complicated.
Yeah. All right. Here's an easy one, last one on this, I think, and then we'll talk about rational ones. What do we do first?
Subtract the 2.
Okay, we subtract, oops, it's a plus x minus 2 is less than 0. Then what? We need exact zeros. Does it factor?
I think so. Probably not. I think it's 3x plus x, x minus 3x minus x. 3x plus all these x's.
All right, we got a 3x squared, plus 1 and a minus 2 gives me 3 minus 2 is 1 in the middle.
Yeah.
Whew, that was painful. Okay, where are the 2 zeros at? 2/3 and -1. Which one goes on the left?
-1.
-1. Positive 2/3. What is the number in between there?
0.
So I could look at the graph, which I did down here.
It's pretty negative.
Okay. Or I could just throw a 0 back in right here. If I put a 0 in, I get -2, so it's negative here. What's it doing on either side of there?
Going up.
It's positive out here. What is the solution I'm looking for? The negative parts or the positive parts?
Negative parts.
Less than 0 means the negative is where it works in here, so we write -1 to 2/3. There was no equal to, so we don't need square brackets.
Yep.
Can handle these. Okay. Rational inequalities are a little more complicated, but we still get to rely on our calculator. when you have a rational inequality, there's two things you have to do. First of all, you have to solve by first writing the inequality in general form with a single rational expression on the left and a 0 on the right. So you want to combine it into one expression on the left, 0 on the right. And then it says you have to find all the critical values, we're going to call them. They're not just the zeros. Because remember how crazy these graphs were? Things happened not just at zeros, but also at the undefined places, or the asymptotes. Is that making sense? The graph started doing crazy stuff on either side of the asymptotes. So it says remember to include all the zeros and the undefined places when you do your sign chart. Okay, we're going to set both numerator and denominator equal to 0 and then test values. Here's a quick example. Okay, multiplied top and bottom to make a common denominator here. Got 4x plus 4. Multiplied this one by x minus 6. You don't have this one, so just pay attention for a second. Distributed the 2, got 2x minus 12. Combined like terms and got this. Now, my sign chart. What are the three values I need? I'll erase that so you can see it. But positive 6, negative 1, and if you set the top equal 8/6, which is 4/3, what's a decimal approximation of that so that we can...
1.3.
Yeah. So just so we're sure we're picking numbers in between. All right, we're going to do this one in our heads. What's the number to the left of negative 1?
Negative 2.
Okay, if I go and put a negative 2 in here, I'll get negative 12 minus 8 over negative 8 times negative 1. That's a negative over a positive, which means it's negative. Okay, what's the number between negative 1 and 4/3?
0.
If I put a 0 in there, I get negative 8 over negative 6 times 1. Negative over a negative is? Okay, what's the number between 4/3 and 6? 5. If I put a 5 in, I get 22 over negative 1 times 6, which is negative. What's the number past 6?
10.
Okay, if I put a 10 in, I get 52 over 4 times 11. It's positive, right? Because it's only positive numbers. I don't know what I just wrote there. All right, so where was this graph greater than 0? Here and here. Okay. Now, I want to talk about something quick before we do this on a homework problem. If this had said greater than or equal to 0, normally I would include all my critical values, right? But can I include, look at the question, can I include 6 and negative 1? Never, ever, ever, because they're making the denominator undefined. So I can't include negative 1, I can't include 6. The only place it would actually equal 0 is where the numerator is 0. So this one would have been a square bracket. These would have still been parentheses. Okay? Greater than or equal to's with rational functions are tricky, which is why I didn't put it on the test. All right, we talked about this already. So this is off your notes. It says you must include the zeros of both the numerator and denominator when you make your little sign chart. All right, you have this question in your notes. It says 2 over x minus 4 plus 1 over x plus 1 is greater than 0. You have to get a single fraction out of that. So you multiply this one by x plus 1 over x plus 1. And the top becomes 2x plus 2. Everybody okay? Plus you multiply this guy by what over what? X minus 4 over x minus 4. So they now have a common denominator. You don't get rid of the denominator, guys. It's just common. And up here you get a plus 1 times x minus 4 is just x minus 4. Add the like terms. We got 3x minus 2. What are the three critical values right here?
4,
positive 4, negative 1, positive 2/3. This is not the same question that we just did, is it?
No.
Okay, a little bit different. All right, I used a table here. What was happening below negative 1? I typed it in, and then I went to the table. I put in a negative 2, and it came out negative. What's the number between negative 1 and positive 2/3? 0. I got 0.5, which was positive. Between 2/3 and 4, I put in a 1, and I got out a negative. After 4, I put in a 5, and I got out a positive. Okay, so it asked where it was greater than 0. What did I want to write down?
All the positives.
Here and here. So it was negative 1 to 2/3 together with 4 to infinity. What's wrong? Okay. If it had been or equal to, we could have included the 2/3 only. Yep, but it wasn't an or equal to, so we're good. Is that what your answers have on there? Yes? We got the same thing, right? All right, let's try this number 5. Ready, set, go. What do we need to do first? So x minus 1 over x plus 2 minus 3 is greater than 0. Now, what do I want to multiply this by to make it have a common denominator?
X plus 2 over x plus 3.
So our common denominator is just x plus 2. What happens up top here when I distribute that? What?
Oh, I meant altogether.
Oh, you guys all simplified already. I'm
Yeah,
like,
I
I'm
like
so
words in my head.
confused. I got negative 2x plus
Yeah,
7.
that's not
That's not what you said. Are we okay? It's minus 7. I lied.
There's a negative there, man.
Somebody is going to decide to change the signs or something. Can you do that?
You change the bottom.
You could change the signs on the top and bottom, or you could change just the signs on the top, but it would reverse this inequality, right? Because you'd be multiplying by a negative 1. Remember the whole rule about flipping the inequality? Okay, we're just going to go with what we have. What are the two critical values, top and bottom, remember? Negative 2x minus 7. Yeah, we got to do this one, don't go back to this one, okay? 7 divided by negative 2, is that right? Negative 7 halves are negative 3.5. And the other one, the bottom is negative 2. Now, do I have them on the right sides of each other?
Nope.
Okay. If we type it in our calculator, I have it somewhere here. It's this one, right? Negative 2x minus 7 over x plus 2. Do I have the right one? Got to put parentheses top and bottom. A couple of you aren't doing that on the quiz and got some crazy graphs. All right, I can look at the graph, but it's easier in my brain just to go to the table and try some values. All right, what do you want to try that's below negative 3.5? Negative 4, negative 3.6, anything will work. I got negative 0.5, which is negative. Okay, what's between negative 3.5 and negative 2? Negative 2 and negative 3.5. Negative 3 would work, or negative 2.2, or... Okay, I got positive 1. What's between negative 2 and infinity? I already have 5 or 0 on here. They are both negative, right? Okay, which is the right answers? The blue ones or the red ones here? Greater than 0, so negative 7 halves up to negative 2. Are we okay? That was kind of painful for some of us.
I'm sorry, Miss Hawkeye. I'm just mad. I get to a point in the day my brain stops working.
I don't know why negative numbers are so tricky for us. And fractions combined, it's just a mess, right?
Okay.
All right. Can you want to try this? Get a common denominator on your own. See what you get. You will lose your critical value of 4. If you find your domain restrictions first and then do that, you'll be fine. But you have to include on your sign chart that negative 4 that was in the denominator, that made the positive 4 that made the denominator 0. Just kidding, it's positive 4. Because there was an asymptote in the original function at 4, you can't lose that. But you will find the other one when you do it your way, yes. All right, I got x plus 2 minus x plus 4 all over x minus 4. I just got 6 over x minus 4. Did I do something wrong?
No, I know that too.
Okay, so the only critical value is at 4. If you did that, you would get no solution, right? If you just cross multiplied the x minus 4 over here, you'd have x plus 2 is less than or equal to x minus 4, which would be 2 is less than or equal to negative 4, which is never true. So then you'd be in trouble. All right, so doing it this way, we have one critical value. What do you want to try? Which side of 4 do you want to try?
527.
How about 0? If we put a 0 in, we'd get 6 over negative 4, which is negative, right? Okay. And on the other side of 4, if we try a 5, you'll have 6 over 1, which is positive. So which side is making it less than or equal to? Okay, less than or equal to 0 means this side is working. Do we include the 4?
Yes. No. I just put that in fine.
We can't include the 4 because it came from the denominator. So we can't include it. It's negative infinity to 4. You can only include values, if it has the or equal to, you can only include values that make the numerator 0. That being said, everybody caught that I said that one on the test does not have, it only has a less than or greater than, right? So I didn't make it doubly tricky by making it or equal to. All right. Doubly tricky. What are we going to do to this guy? What's the comment? It's already greater than 0. We're in luck there, but what do we need to do?
Multiply 1 by
X minus 4 over x minus 4. And this one by x plus 2 over x plus 2. Our common denominator will have an x plus 2 and an x minus 4. But right here we get an x minus 4. And this one is a 3x plus 6. Miranda got 4x plus 2, and she's pretty much thinking she did it right this time. What do you think?
I'm pretty proud of myself. Apparently I can't do that.
I wrote fast. Everybody okay? You can take a 2 out of the numerator. Then you'd have 2 times 2x plus 1. Either way, what's the critical value we're talking about from the numerator?
Negative 1.
There's 1 at negative 2. There's 1 at positive 4 from the denominator. And the one from the numerator is at negative 1/2, even if we hadn't factored it, right? We'd get negative 1/2. Where does negative 1/2 go? In between. Okay. Now, if we go in our calculator and we type 4x plus 2 over, we'd need extra parentheses here and here. Let's see if I have that in my calculator. No pressure. You know what? I don't, because, oh, I just erased it. I had it in this original version. Now I'll type it in this way, I guess. It's 4x plus 2. Sorry, that was a bad noise. Divided by parenthesis, x plus 2, close parenthesis, open parenthesis, x minus 4. Double close parenthesis. I need to go back up and delete this one that was turned on since I don't need it. All right, this is what the graph looks like. But more important, I want to know what's going on between those critical values. So I'm going to go to my table. All right, I need something to the left of -2. Oh, I got something already in there.
7.
I have -4 or -3, either one already in there, and they came out what?
Negative.
Negative. What's between -2 and -1/2?
-1.
-1. Good job. Okay. If I type, oh, come on, stupid thing. If I type -1, enter, I get 0.4, which is a positive value in between there. What's between -1/2 and 4? 0 was, right? So you can put in 3. You want me to put in a 3? Either way, even at 0, it was negative. And then beyond 4, out at 5, it was positive. Okay, so where is it greater than 0?
In between -2 and -1/2 and 4 to infinity. Yeah. Here 5.
Okay, we good?
Uh-huh.
Okay, the assignment on this is only one side of worksheet 15. I think it's 15A.
Yes.
Okay. Oh, we have one we didn't get to.
It's okay. Wait, it's like the other one. It's really close. That's right.
I mean, we've already done one like that. Yeah.
This one just got some more numbers in it.
I get 5x minus 1 over 3x minus 2 is greater than or equal to 0. Which one of those values can I include?
1/5.
Okay, I have 1/5 and 2/3.
You can include 1/5.
And I can include this one.
Mm-mm.
Zero's down here. If I put in a 0, I get a positive number. So I'm thinking in here it's negative and then positive.
You would be right.
So where is it going to work?
Everywhere from -infinity all the way up to and including 1/5. What's that from?
And why can't I include 2/3?
Because it's undefined.
Makes the denominator 0. See, we got this one done. You guys are... All right, so the assignment is to do 15A, and while I'm gone tomorrow, you're also going to work on 16 and 17, yes?
There we go, guys. That's what she is
If
now.
you are taking a quiz, you need to sit separate from everybody, and everybody who's not taking a quiz needs to be quiet so that the people who are taking the quiz can get it done.
I used to cancel tomorrow morning.